what actually is MongoDB. So before actually going into the MongoDB thing, the first question comes, why was the need of MongoDB? Like there were, RDBMS, softwares available with us. There was SQL Server, there was Oracle. They were doing pretty good. So why the, rise of these NoSQL systems and all? Because the thing which was being felt all over was the amount of data is getting increased, very frequently, and the kind of velocity, volume, variety that data brings in, the relational RDBMS systems weren't actually able to grab things up and process that. Like, SQL Server or Oracle can easily take up to, 1 TB of data, but when it gets, up to the frequency of 1 TB, we can actually see the SQL Server and the Oracle struggling a bit in terms of efficiency and processing. So that was where, a thing came up, because, Twitter and Facebook are coming up with their own things, and we can actually see, like, you have an account, I have an account. Daily we are doing so many things on Facebook, Twitter. We are subscribing to some guy. We are, tweeting. We are commenting. So everything is getting stored somewhere, and all of these stuff, they don't have a schema in place. So we needed something which is actually schema-less, where we can add, whatever we can. We can write once into the database and read many times. We wanted some kind of a system, and there was, this Hadoop, the big data, the MongoDB, the NoSQL, all these things came up. So NoSQL in general, basically when it comes, that is the reason in the first slide I've specified in the beginning, in the middle it's big data, to the left it's MongoDB, and to the right it's NoSQL. Some people think, NoSQL is something completely, out of context with SQL, but it is not the case. NoSQL is, the SQL will be used as such as it is used earlier, but it is SQL plus something else. So that is not only SQL, we will be using some other features which will come into place. Yeah. So here is, what I was telling about, with the growing advent of data in the, years, it's a Gartner's report by 2015. The digital world will actually be inundated with close to 5 zettabyte of data. So gradually what we're actually seeing is the RDBMS, which once used to rule the market, this, deck, which actually will actually give, some guys a shiver, because, it's actually till now it's all RDBMS, but the changing data landscape, as predicted by Gartner, will gradually the RDBMS will go into the backshield, with only the transactions, getting transactional based systems getting the RDBMS, and the NoSQL is actually having the big chunk of the database management software systems. So, and in this NoSQL we have so many different flavors coming in, like, we have the graph DBs, we have the document DBs, we have the key value stores. These are all different flavors of NoSQL, like, so in that Apache Cassandra, MongoDB, HBase, Hive, Neo4j, they all come in. So the thing we will be concentrating on today, our thing is MongoDB as a part of the NoSQL catering to the big data problem. So the agenda for the today's presentation will be covering what is MongoDB, where actually relational databases go with the MongoDB, what is the difference between where does MongoDB stands out. The third point will be what actually MongoDB will achieve, which the earlier RDBMS systems were not able to achieve. Then we'll go into what are the key features of MongoDB, and then the two very important questions: why MongoDB, and when we need to actually have the MongoDB thing in place. So now, what is MongoDB? So MongoDB, we can say, is a document database. When I say a document database, in that I mean everything will be stored in a document. To be more precise, when I do it in RDBMS, suppose I have a collection in RDBMS, suppose I have a table employee, and there are two employees, one is Amit and one is Namit. So what will happen is two columns will be framed, one will be the name, one will be the age. So first row would be Amit, his age, and will be Namit, say 23. So that way RDBMS used to work. In MongoDB what will happen is, here the analogy to table is a collection. Here we won't be having a table, we'll be calling that same thing as a table as a collection. So MongoDB consists of collections, and in collections we have documents. Like coming to the RDBMS paradigm, we had tables. In tables we used to have rows and columns. In MongoDB we'll be having collections. In collections we will be having documents. So MongoDB, the name has actually come from, humongous. When we say humongous, humongous is very large. So with the humongous we have took the Mongo, and there the MongoDB comes in. So MongoDB is actually able to handle a very humongous volume of data. That's where the name has come. It's very scalable, it's high performance, it's open source NoSQL database which is written in C++. The data, the language in which it is written is C++. And when I say it is scalable, by scalable I mean MongoDB and all the NoSQL databases, they are highly scalable. The RDBMS databases, they were not scalable. By scalable I mean all these NoSQL things implement, just wait a sec. Yeah, all the other, all the NoSQL things are highly scalable. By scalable I mean they all implement, just wait a sec, all implement a concept called, a technology called commodity hardware. It's like all the data won't actually be stored on one node. It will be segregated across a cluster in which the data will be distributed among a cluster, among different nodes in a cluster. In that way, the database becomes scalable. We can actually scale it. And all the RDBMS things, they used to actually be vertical scalable. Like, we have a SQL server and the data has grown up to, a certain limit in which the server can't actually able to handle that. So in that way we increase the capacity of the server. We can increase the hard disk, we can increase the RAM. So that is called vertical scalability. We're increasing the capacities of the individual server. The scalability which NoSQL systems and the MongoDB specifically comes up with, horizontal scalability. When we want more data to be accommodated in the database, we horizontally scale the system. We add a commodity hardware and we distribute the data across that. So that was what was scalable all about. It's high performance because of the fact, like, the data, it's actually able to handle a very large amount of data in the processing time, because it's all distributed. It gets faster, and it's open source. We don't need a license for that. So that's the first thing. So new database technology like MongoDB is the need of the day to facilitate. That's the same thing which I told, like, the horizontal scaling of the data layer. And yeah, so very interesting thing is, why among all the NoSQL databases MongoDB is actually coming up. One very big reason for the same is all the social media sites, they in general produce data in the JSON format, and the native format in which MongoDB comes up with is also JSON. So that's like, the internal compatibility is very easy between all the social media sites like Facebook, Twitter, Orkut and all those things, LinkedIn, with the MongoDB, because in general the native thing is still the JSON. So the JSON, it's actually a JavaScript object notation. If I actually abbreviate it, it becomes JSON. So JSON is nothing but a key value pair. Like, and the front thing, if you see to the left image, MongoDB, behind that its name is the key and Mongo is the value. Type is the key, DB is the value. So this is one document. In this document, we have two keys. One is name, one is type. Mongo thing has been assigned to the name key, and DB value has been assigned to the type key. So we can say in a RDBMS paradigm, the name and type are two columns, but In MongoDB, we don't call them this column, we call them as keys. Everything is stored in the form of a key and a value. So from this example, it will be very clear. The thing named Mongo type DB is a document in which name and type are the keys, and Mongo and DB are the values. So yeah, and the way MongoDB stores data is in the BSON format. And the BSON things gives us, gives MongoDB a flexibility to actually retrieve the data in a much faster pace, because everything is binary serialized. Everything is stored in the binary form 010101. So that makes the retrieving out very easy. So yeah, before coming up to relational databases, where MongoDB stands out, where is the difference between them, I like to summarize what actually MongoDB is. MongoDB is a document-based database which helps us in handling the problem of big data. And one thing which puts MongoDB in a very special place in this thing is scalability. We are actually able to scale things up on different nodes. We are able to place it. And to summarize it even more, the native language of the native format in which the MongoDB stores things is JSON, and it is actually built in C++. So things to carry it forward, in the mind, so that we can actually take things easier. The next process is MongoDB is a document-based database, which the internal native language is the JSON. Yeah. So when we compare MongoDB with relational databases, relational databases was developed by EF Cod of IBM, whereas MongoDB, the company behind having MongoDB set up is Tengen. That is the company which has made MongoDB. One very special feature of RDBMS used to be a certain schema. There was a certain schema in which the rows got inserted. Suppose we have created a table, and we've created a table called employee, and in that we have three columns: name, age, sex, and occupation. So a certain schema has been formed, and we'll be inserting rows according to that. So if I need to add another row of Reshma, so the Reshma record needs to have the name, age, sex, as well as occupation. One of them can go null, but we have to specify that specifically. So everything has to go according to a schema. We can't add one column, we can't delete one column. So whereas MongoDB is schemaless, and what I mean by schemaless is, there is a collection called employee. Please give a bit of note to my words. In RDBMS we had a table called employee. In MongoDB we will have a collection called employee. There I had two rows, Reshma and Namit. In MongoDB, in the collection employee, I'll be having two documents, one of Reshma and one of Namit. So the thing which stands out is, if I want to add a third record, a third document, Amit, and the only information I want to give of Amit is the name and the age. I don't want to disclose the occupation. MongoDB allows me to do that, whereas RDBMS won't allow me to do that. In MongoDB, I can add a third record. I can only give the name and the age with the Amit record. And the key in all the three things would be the name, Amit, Namit, Reshma, and all will be the values. Now I want a fourth record which actually has 5 columns. His date of birth is also into the record. So I can actually play with the schema. I can easily add columns. I can easily delete columns also. Whatever be my requirement, if I want to add 100 values to that key, I can do that without altering the collection or the table. In RDBMS, when we have to do that, we need to alter the table structure first. We need to add it, and then also if we have increased the column thing from 4 to 5, we need to actually, when we enter the next record, we need to enter 5 columns itself. The next thing is, but RDBMS used to come with a very rich set of functionalities. from joins to transactions to querying to sub-querying. RDBMS used to give us a very huge rich set of functionalities to handle the data, whereas MongoDB in general is comparatively thin when I talk of functionalities. Two very big features which MongoDB does not give, which RDBMS used to give, was one is the joins and one is the transactions. We can't do joins in MongoDB. We can't use transactions in MongoDB. People learning MongoDB on the very forefront, if they are told we can't be we won't be able to do transactions and join in that, they'll be a bit surprised, what is happening? Why not this? But the kind of places where we use MongoDB, there we don't actually need transactions. We don't want transactions to keep in place. I'll come to that topic further, why the joins and why the transactions, even when we are not able to do that in the MongoDB, why that is not a showstopper or a roadblocker here. Yeah, RDBMS could have handled only structured data, as I told, we need a schema in place. We'll enter the data, it'll be entered as a as the schema is specified. Whereas in MongoDB, there is no such schema. Even if the data is unstructured, in the first record we have 1 column, and the second record we have 100 columns. So we don't actually, even the unstructured data can be handled using that. So vertical scalability and horizontal scalability, I've just told. Vertical scalability is we increase the capacity of the server. In RDBMS, if the volume goes across a certain level, the data is not able to handle, we'll increase the capacity of that individual server. Whereas in MongoDB, we'll add one more node to the system, which will be horizontally scalable that. Yeah. Now, very good, difference between RDBMS and MongoDB is the RDBMS, the basic structure of RDBMS is, the principle in which RDBMS works is ACID. ACID is atomicity, consistency, isolation, and durability. Whereas MongoDB, just the opposite, it uses base. What I mean by base is, if I make the full form of base, it's basically soft state eventual consistency. What I mean by S here is soft state. Just imagine we have a MongoDB cluster in which I have 4 nodes. Then what I mean by soft state is, in this NoSQL system, the MongoDB, the primary structure will be MongoDB will run on a cluster. A cluster will have different nodes. Suppose I have a cluster in which there are 4 nodes. 1 node is acting as the primary node. The 3 nodes are acting as the secondary nodes. Suppose in a collection I've actually entered some values, and I've entered some values, and it is not actually consistent with all the other nodes. Suppose I've written 3 records to the collection, but I won't be able to see those 3 records replicated in the other nodes instantly. Like RDBMS, suppose there is an application, a transaction-based application where I'm withdrawing 100 rupees, so immediately it is being reflected to all over the account whenever the place X is there. But in MongoDB, the thing is, the changes will happen, but it will employ eventual consistency. Things won't be consistent across the nodes, across the cluster. The reads, the writes will depend basically on the time frame. So the next thing I come is the same thing. The RDBMS stresses on availability and consistency of the data. The data is available as well as it is consistent all across. Like the same thing I withdraw, across the account 100 rupees, it will be available as well as consistent. What I mean consistent is, suppose I'm accessing, I went to a ATM, I withdrew 100 rupees from an account. My first balance was 1000. So after that, the balance would be 900. So when I say consistent, if at the same time I try to withdraw that money from the same account somewhere else in India, it will be consistent across. It will be 900 showing everywhere. But in MongoDB, it won't be the same case. it'll take time to become consistent. The sync will happen after a certain period of time. So RDBMS employs full consistency, whereas the MongoDB, what it does is it's eventually consistent. The same thing I told, it's eventually consistent because of the asynchronous updates happening. The RDBMS is synced all across. The changes will be, reflected instantaneously, whereas MongoDB will take a bit of time. Then in RDBMS, the data is normalized. The tables are segregated on the basis of keys, whereas in MongoDB, we take the full data, it's all denormalized, because the purpose MongoDB is used is actually for doing analytics over the archive data or big data. So we don't actually want the thing to be normalized. The more denormalized the data, the better analytics will be able to do over top of that. So as I told, RDBMS, it helps in transactions. So it's very efficient in handling OLTP data. OLTP is online transaction processing. The same thing, because it is consistent all across. OLTP, for OLTP, the obvious choice even now, it's actually relational database systems. So for doing OLAP data, OLAP is online analytical processing on a warehouse. If I want to actually have insights over in the next 1 year, where should I, if Coca-Cola comes up to me and say we want to set up a store somewhere in India, so they will give us the data, past 10 years, 20 years data, and doing analytics over that data and telling them, advising them where we can put up the next store will actually, in that case, MongoDB will be helpful. Yeah. So what actually MongoDB will achieve, which the RDBMS were not able to do? In this graph, you can easily see the x-axis is depth of functionality and the y-axis is scalability and performance. We'll see RDBMS first. So what RDBMS used to offer was a very high level of functionality. The kind it had very rich set of functionalities, from the grouping to the joins to the transactions to the subqueries. We could actually able to employ any function across the database, whereas it was not scalable, as well as the performance issue used to come when the data used to go across a certain level. So we can vertically scale the system, but the scalable issue and the performance issue was always there with RDBMS. And there were the mem cached and the key value stores. A key value store, Dynamite is a key value store. So in these cases, one thing was they actually gave very high scalable systems, and the performance was also very high, but the kind of functionalities these DBs used to offer, it's not that great. We won't be able to actually manipulate that data on a very large extent, though the scalability and the performance thing has gone up. So MongoDB actually gives us a very, without the trade-off between scalability and performance, we can have both the things in MongoDB. Though the depth of functionality is a bit less than the RDBMS, the scalability and performance thing is on par with the mem cached and the key value stores. So without compromising much on the functionality, MongoDB is able to actually scale our system and give us better performance. So this is where MongoDB stands out, and you can easily see it bridges the gap between the key value stores, which are fast and scalable, and the RDBMS. So here I've specified no joins are there, but we can do the document transactions. The concept which MongoDB comes up is everything will be stored in documents, but we can embed the documents. When I say embed the documents, if I have one record as Namit with some values, I can actually initiate another document within that Namit document entailing the list which Namit will be attributed with. So while we will be doing the practical thing, that will be more clearer then. So fast scalable read write, because it is distributed and scalable all across the system. We're able to read the things very easily and with a much faster pace in MongoDB. Yeah. So key features of MongoDB. The first thing is the JSON data model with the dynamic schema. The JSON I've told everything will be stored in the form of a key and a value. That is the data model being followed in MongoDB, and the schema would be dynamic. We can say in RDBMS the schema is static. By dynamic schema, it's like, the gist of the thing I've already told you is just we need to, keep the frequency up. Like dynamic schema is the same thing. The schema is not fixed. We can actually, add the columns. We can actually delete the columns as our wish. Flexible full index support. Though it is a NoSQL system, we can actually, put indexes on the collection on the particular keys we want, and that will help in, the performance optimization and things. Yeah. Another very, important thing which MongoDB comes up with, replication. There was a very big danger in the case of RDMS system. If we have a SQL server, if that SQL server goes down, it crashes. We can take a backup of that, but that was very jittery. So MongoDB comes up with the replication thing. The data will be replicated all across the cluster. It won't be like, the data, if one of the node in the cluster has gone off, we won't be having the data. The data will still be accessible across all the nodes. If I go in a bit deep to tell you what and how replication takes place is, suppose I have a 100 MB file and I want to store that 100 MB file into MongoDB. What MongoDB will do is the 100 MB file will be divided into 4 different parts, say A, B, C, D, 250 MB each. And every node will have one chunk or the other out of this A, B, C, D. Suppose the node 1 has A, B, and D, the other one B, C, and D, other one A, C, and D. Similarly, randomly it will be assigned to the nodes. So even if the node 3 goes down, the primary node will actually be able to aggregate all of the chunks placed in A, B, and D and get the full ABCD thing up, and I'll still be able to retrieve that 100 MB file, 1000 MB file. So replication helps in that way. 2 features are there in MongoDB which, are actually which were not there in the RDBMS. That was, one was replication, one was sharding. So replication, I feel like, we are done with that. Sharding I'll be covering. So the next point is aggregation framework and MapReduce. You would have actually, heard all the fuss around the MapReduce and things coming in. So MongoDB also has its own MapReduce running, though we can run our custom MapReduce run in Python or Java. We can also, there is a, MapReduce inbuilt of MongoDB also which we can use. And by the aggregation framework, I just explained you, the data will be segregated into chunks and will actually be stored in all the different nodes. And while we retrieve that, it will be aggregated across different nodes and presented to the name node. When I told joins, so we won't be able to actually do the join between separate tables, but aggregation framework allows us to actually group by the tables. Like, we used to do group by in RDBMS, select star from table, group by some particular column. The same thing we can actually do in the aggregation framework using the aggregate function. So, and the third thing is auto sharding for horizontal scalability. Horizontal scalability, I feel, up till now, So, auto sharding. Auto sharding, if I can explain, not every document will go to one node. We'll be specifying a shard key for each document. When I say I'll be specifying a shard key for each document, suppose I have 100 records, 100 names which need to be entered into the employee collection. I'll add one more key, one more column to the full collection. I'll name it as shard key, and I'll give 1, 2, 3, 4, 5, 6 up to 100 as the shard keys. I'll specify 1 to 25 shard key should go to node 1, the 26 to 50 shard key should go to node 2, 51 to 75 to node 3, and 76 to 100 to the node 4. So what I've done is I've ensured that according to my requirement, I'm able to segregate the data into different nodes. So this is the concept of sharding: replication, sharding, and the aggregation. These three things form the backbone of MongoDB. If I'll actually sum it up, replication is done to avoid a failover, which can happen in a case of RDBMS system. If the SQL server, if the server goes off in RDBMS, we're actually in a lot of trouble. But in MongoDB, if one of the node goes off, we still don't need to worry. We'll be able to retrieve things because the chunks of the file are replicated all across the cluster. The second thing was sharding. In sharding, what we do is we specify, we distribute the data set we have according to a shard key. We specify which shard key data should go to where, and when you want to retrieve it, suppose I want to retrieve the document, with the shard key as 52. Just when I specify I want the 52, record to come up, it'll actually know I want to go to node 3. The primary node will, because it'll have the metadata about, where all the things are stored. The primary key will know the 53rd document is actually stored in node 3. It'll go in there, it'll retrieve the things, and we'll have the data. And the third thing was aggregation framework. Aggregation framework is like, the same thing we'll be able to do the group by things. All the chunks will be aggregated and thrown back to the primary node. And then there are one very common thing which people ask is why MongoDB is actually able to stand out across other NoSQL systems also. We have Apache Cassandra, we have Neo4j, we have Dynamite. What is there in MongoDB which stands out? So MongoDB is very SQL-like, and it won't give you a feel like you've come to a completely different world. MongoDB presents a SQL-like framework where we can write SQL-like queries, and that too with high rich set of functionalities, not of the sort of SQL, but still we can actually manipulate the data far better than the other NoSQL systems available with us. And for when I say normal tables, normal records, will be actually able to store, but what will happen if I need to store a blob, binary large object? So in case of blobs, MongoDB has a separate file system in place to cater to the large documents. Suppose I need to save a video file of 500 MB. So MongoDB has its own grid file system. GridFS is grid file system, which will cater to storing all the blobs, all the images, all the videos will be stored in the similar fashion. In GridFS, suppose I take the 500 MB video, the 500 MB video will be broken down into chunks, and those chunks will be segregated, replicated, and stored across all the nodes in the cluster. And when I need to retrieve that video, I'll be able to retrieve that using the aggregation framework. The primary node will know where all the chunks are actually located, and I'll be able to get back. And I'll able to get in their replication as well. Suppose 4 nodes, third node is gone off. We don't have the third node. And will I be able to still retrieve the video? The answer is yes, because the chunks, the file has been divided into chunks, the chunks have been segregated, replicated, and stored. For every chunk, we won't be having one value, we'll be having different values. We will be setting up a replication factor. Every chunk we need to replicate how many times. So we will take up it as the normal default thing is 3, because that chunk will also be available in different nodes. We'll be able to still retrieve that thing. So to sum up this slide, MongoDB, it employs a JSON data model. It also, we can also do indexing in that. Three things which stand out are: one is replication, one is sharding, one is aggregation framework, and it is very SQL-like, and we use GridFS for storing the large thing which divides the file into chunks and store them into different nodes. Yeah, then thing comes, I've actually covered them, covered this slide in the, previous slide itself. Why actually MongoDB? Because, it's very agile. We don't need to stuck somewhere. We don't have a fixed schema where we need to do things at. When I say it's agile, by agile I mean it's continuously incremental approach. It's not like I fix the schema, I'll be doing things accordingly. It'll be like, as my requirement goes, if I want a record with 1000 columns, I'll be able to do that. If the next record comes with only 2 columns, I'll be able to do that also. So within the agility comes, the MapReduce thing for the better data processing. And the second thing which scales out is scalability. The same thing in the RDBMS things, we used to have the vertical scalability. Here we will be able to actually scale out the system horizontally and allow users to build and grow applications more rapidly. The third point is, I didn't cover auto sharding. One thing in which MongoDB, we also have the sharding thing available in Apache Cassandra and HBase, but they don't come up with the auto sharding thing. What MongoDB will do is, we have specified the shard keys, but we have not specified which records should go where. So to do that, what happens is, what we do is, the primary node will know how many nodes are there in the cluster and how many records are there in the collection. On the basis of the number of nodes and the number of records in the collection, it will auto shard the collection and will store it. Now a very good questions come up. When we need to shard, we need to shard it by collection or we need to shard by database. So it's always recommended that we shard by collection so that the primary node knows where our data is, so that it can actually go to that node and retrieve the thing. And the next thing is enterprise readiness. It's actually, some people say when Hadoop is there, MongoDB won't able to come into picture because Hadoop has took all the limelight and all those things. Hadoop is the thing driving. But in Hadoop, the configuration part is very, very difficult. We have separate things for everything. While MongoDB presents one single interface where we can actually do the replication, do the sharding and all those stuff. And the data integrity, it was not earlier in the MongoDB previous versions, but the MongoDB new version 2.4 which has come up, it has come up with the journaling and the write once thing. By the journaling, we can, while writing data to a collection in MongoDB, we can actually set the journaling and the write once is true. We can set the journaling true by, by setting j is equal to 1 and the write once by w is equal to 1. We can add these parameters in the query. What this thing will do is, it will ensure that before the record is written into the disk, it is synced across all the nodes in the cluster, so that even if one of the node is lost or the power gets off or the node is crashed, because it is synced across all the nodes in the cluster, we'll still be able to get that. So this was the new feature which was added in the MongoDB 2.4. So the next thing which comes up is, we now, I'm pretty sure by now we would have a very clear understanding of, what MongoDB is, from where it has come, why it has come. But when we should actually apply MongoDB, how we should distinguish which applications we need to go for MongoDB, where we used to do RDBMS, and where to put in Hadoop. So when MongoDB, whenever the data is unstructured, RDMS won't be able to handle that, and in that case, the MongoDB can come into place. Rich data models then don't require joins. Similar way, where the transactions are not there, where we won't require joins to be done on the tables, there we can use MongoDB. Analytics. Every type of application, the website activity tracking, suppose I have a website of my own, a person, X has a website of his own, and he wants us to, do some analytics over who all users are logging into my website since April 1st. Suppose he wants to know, since April 1st, 2013, how many registered users have logged into my website, for how much time, from which geography they have come, and who all anonymous users have logged into my site. So all this information, if that guy knows, if that guy wants, we can actually have the weblog, from the web servers of his, stored in the website. By getting the weblog, we can process that into MongoDB, and we can do, we can apply the aggregation framework thing on top of that weblog and get the analytics going in that thing. So yeah, high availability. High availability was one thing which was not, there with the RDBMS thing. It was not highly available. If the server goes off, the thing used to go off, though we used to have backups, but things were pretty shabby over there. So because MongoDB is actually, the replication system is very strong, so it is actually automated failover. If one of the node goes off, now the question arises, if we have 4 nodes in a MongoDB cluster, if one of the secondary node goes off, we don't need to worry. We'll be still able to retrieve the data because it is replicated. But what if the primary node goes off? The primary node has all the